Welcome to Robo's Physics Adventures. The first topic is measurements, and the first lesson is on fundamental and derived SI units. Today Robo is having a bit of issue with its circuits. Its sensors are noticing a very high temperature reading within the CPU section. Mr. S and the student decide to try to help Robo. They get into the physics truck. By a push of a button, the truck shrinks to the size of an atom. Then they enter Robo through its mouth. Robo is wirelessly connected to a camera and a microphone from the physics truck, monitoring what's happening so that it can learn from this journey. Mr. S says that today's lesson is about the International System of Units, or SI, base units. These units are a fundamental part of measurements and are a common language that are used internationally. As the physics truck enters Robo, the bus goes dark. In order to see, Mr. S turns on the physics truck's headlights. The headlights allow students to see. Mr. S states that candela is the unit that is used to measure the intensity of light in a given direction. This unit will not be covered much in this course, but it's important to know that the design of the light source can significantly change the candela rating of the light. Note that 1 candela of light is approximately equivalent to the light intensity from 1 candle. Having more light is definitely nice. Students noticed that the atoms inside Robo were moving, rotating, and vibrating. Mr. S stated that these 3 forms of motion can help to determine the temperature of the object. We will cover the proper definitions later, but for now, temperature is related to how fast the particles move, rotate, and vibrate. Temperature is measured by the unit of Kelvin. At 0 degrees Kelvin, particles have no movement. As temperature increases, the particles start vibrating, rotating, and moving at higher rates. Students confirmed that they're noticing that the physics truck is becoming very hot as the particles inside Robo are vibrating faster and faster. Mr. S turned up the AC. Since Mr. S had forgotten to add the sufficient fuel into the truck and the AC was taking a significant amount of power, he decided to use physics to their advantage. He used quantum tunneling to enter inside the conductive part of the wire. Mr. S then pressed the button to introduce the property of charge into the vehicle. The truck became negatively charged and it automatically started moving with similar looking particles. There were millions of particles beside them traveling, and Talisa, one of the students, asked, "What are they?" Mr. S explained that they are electrons. Similar to the truck, they are negatively charged and therefore are pushed away from the negative electrode of the battery and pulled by the positive side. In this case, we are all traveling towards Robo's CPU. Jeff, one of the students, said, "Since we are moving through the wire, are we creating electricity?" Mr. S said, "Yes, actually, the next SI base unit that we want to discuss is ampere. This is a unit that measures the electric current. 1 ampere is approximately equivalent to 6 times 10 to the 18 electrons passing through a cross-sectional area of a wire every second." Jeff said, "That seems like a very large number." Mr. S responded, "Absolutely. But you have to keep in mind that there are a large number of atoms inside this conductor, and they have multiple electrons. Therefore, even if these electrons are moving slowly, we can produce large electric currents." Jeff asked, "Why are the electrons moving slowly?" Mr. S told him, "Well, there must be something slowing down the line somewhere along the wire. These blockages are strategically placed by engineers to slow down the movement of electrons. Jeff asked, "Could we increase our speed? We'll never get close to the CPU if we're moving this slow." Mr. S turned a dial and the charge of the truck increased. The students felt a push and the truck started to move faster. As the truck finally got to the CPU and the truck quantum tunneled out of the wire, Miriam, one of the students, noticed that the cooling fan is filled with dust. Mr. S pushed a button that pushed air through the fan at very high speed, and the students witnessed the dust particles falling all over the place, and the fan start to push the air out of the CPU much easier. As the particles in the CPU started to move slower, Robo started feeling better, and its CPU temperature started dropping significantly. Robo said that this has been a tough 20 minutes in its lifetime and thanked everybody for helping. Mr. S used this opportunity to say, "Note that seconds is our next SI base unit. It's used to measure time. There are 60 seconds in 1 minute and 60 minutes in 1 hour." Sarah asked, "Why divisions of 60? Isn't everything divided into divisions of tens or hundreds?" Mr. S acknowledged that this was a fantastic question. This division comes from a long time ago. There are advantages and disadvantages of dividing the time in this manner, and certainly there are big advantages of changing this system, but this requires much longer discussion that we can do at another time. Caroline asked if they can start heading back, and Mr. S agreed, mainly worrying that they might not have enough fuel to make it. Caroline asked, "How far do we need to go?" Robo measured the length of the wire from its CPU to its mouth. The length was 30 centimeters. Mr. S said that the SI unit for measuring length is meters. There are 100 centimeters in 1 meter. Centi is a prefix used for meters to indicate that the number should be divided by 100 to get the equivalent unit in meters. We will discuss prefixes in more detail later. For now, let's measure the time it takes to get back. We can then use the length and the time to determine our average speed. The truck then quantum tunneled back into the wire, in which the electrons were moving towards Robo's mouth. As the truck entered the conductive portion of the wire, Mr. S pushed a button to change its charge and another to reduce its mass. Pedram asked, "Why did we reduce the mass?" Mr. S said, "Reducing the mass of the truck allows it to change its speed to a higher value for the same push from the energy source." We will discuss this topic in much more detail later, but it's important to know that the SI base unit for measuring mass is kilograms. 1 kilogram is approximately the same mass as 1 liter of water. Pedram said that he has a 1 liter bottle to keep himself hydrated. He then passed around the bottle to other students to experiment to see how hard it is for it to speed up or slow down based on their push. Pedram then asked, "I wonder how many water molecules are inside this bottle?" Mr. S smiled. "Well, that's an excellent question. Our last SI base unit is the mole, and it's used to measure the amount of substance. 1 mole has approximately 6 times 10 to the 23 particles. Your bottle of water has approximately 56 moles. The product of these two numbers will give you a very large number, which would be equivalent to the number of water molecules in the bottle." Pedram said, "Mr. S, I was just asking a random question. You seem to know a lot of random facts, but that's really amazing that there are so many water particles in here." Finally, after about 5 minutes, the truck managed to exit Robo. The truck turned back to its original size by a press of a button, and then the students got back to the class. Mr. S said, "The units we discussed today are fundamental units. The International System of Units decided that these units can help derive any other units. These units help us to measure length in meters, temperature in Kelvin, time in seconds, mass in kilograms, electric current in ampere, amount of substance in mole, and light intensity in candelas. All other units are called derived units." An example would be the unit for average speed. Our average speed on the way back was the length of the wire, 30 centimeters or 0.3 meters, divided by 5 minutes or 600 seconds, which gives us an average speed of 0.0005 meters per second. This unit is a mixture of base units of meters and seconds. Therefore, the unit is what we call derived units. Any unit which is derived from our base units will be derived units. We will see many different units in our course, but for now, let's take a rest and continue later. Students were a bit tired from the trip. They saw an overwhelming amount of information and they looked forward to learning more details about the world around them. Robo was especially happy that its CPU was responding well and it was looking forward to the next physics journey.